In the name of God, the most gracious, the most merciful. Dear students, today we talk about yet another flip-flop, okay? And this time this flip-flop is called as the JK flip-flop. So what is the JK flip-flop? In the previous video, we talked about the D flip-flop, how it removed the 1-1 state, which was unreliable state. Okay, so we had a NAND gate here, okay, and we had another NAND gate here, and they are tied together like this. We know that all the time now. And we got a couple of NAND gates also here as my clock, and I put up the inputs using that. And we had in a D flip-flop, what we had is we put up a complement here and give this to this gate, so the 1-1 state never comes. If it is 1, it's going to be 0. If it is 0, it's going to be 1. So 1-1 state never happens. Okay, now I want to have this 1-1 state and put it to some use. So that means I am going to remove this inverter, right? So if I'm going to remove this inverter, so I'm revisiting to my the previous SR flip-flop. So this is no more D, okay, and this will be the previous SR flip-flop. But I'm not going to write it SR because SR flip-flop, the 1-1 state in the SR flip-flop was unreliable, and I have to do something to make a new flip-flop, which is putting that 1-1 state to the use. Okay, so that means I have to do some additional job here. So what I'm gonna do is I put up the additional feedback loop, like with a feedback loop here. That's why it's a sequential circuit. And now we put the additional feedback loop so that that 1-1 state is put to use. So then it will become the J, the K flip-flop. So what shall I do? So what I do is I put up here, this is my Q and this is my Q complement. I put up the additional feedback loop from here, and I go here and come back to this NAND gate. And I put up another feedback loop from this Q to this NAND gate. Okay, now these NAND gates have the 3 inputs. Okay, I'm getting additional. If you have the same SR flip-flop, sorry, and you put up the additional loop from Q back to this gate and from Q complement back to this gate, it will become JK flip-flop. Okay, it is so simple now. The JK flip-flop is nothing but additional feedback loop. Come back here and come back here. Simple. Now, how will it work? Let us see how will it work. It works exactly same for all the states, like 1-0 for set and 0-1 for reset, okay? But for 1-1 state, it is not unreliable. It is doing something. Let us see what it does. And by the way, we don't call it SR, we call it JK flip-flop. Okay, so it is same SR flip-flop, but the additional loop, feedback loop, right? Q coming back to the down gate and the Q complement going back to the top gate, top NAND gate. Simple as it is. So how will it work? Let us see. Let's try to see it. Okay, for all the 1-0 state and 0-1 state, it will work same, and 1-1 state, what it is called, it will toggle. So what is that? Let us see. Let us see first the other states. If the clock, this is my clock, okay, this is gonna be my J input and K input. Right now we had S and R, now we have J and K. Maybe I make it a little right so that it doesn't go off the screen, and maybe I use different pin. Okay, I use this pen. Let me see how it works. So this is my clock. Okay, this is my J input and K input, and this is gonna be Q and Q complement, and this is gonna be the state. Okay, now if the clock is 0, we know from the SR flip-flop, it's not gonna work. It doesn't have any effect. If the clock is 0, it's gonna be disabled, right? Now if the clock is 1, maybe I use some bright pen. Maybe let me try this one. If the clock is 1 and J is 1, K is 0, okay, but because this has the additional to this, like into these this latch, which was internal. This is our basic latch, right? This one is my basic latch, the dashed one. In this before inputs, we also need to see what was the previous output. But here, to this NAND gate, we also need to see what was the previous output. Say for example, it was a set state. So it was set state, that is 1 0. And I'm putting up J1 and K0. J1 and K0. Okay? And I have to see what will be the Q and Q complement. And I'm saying that, say for example, it was in a set state where the Q was 1 and 0, because the output of the previous output also becomes the input to this NAND gate also. So before talking about these inputs, we have to also talk about what was the previous output, right? Because it has the feedback loop. So we cannot say the current input gives me the output. No, the current input and also the previous output, we have to see together what behavior it will show. Now right now, say for example, I take it was set. It could have been reset, it doesn't matter, set or reset. So I'm taking one option, it was set. And I'm making J1 and K0. J is like your S and K is like your R. So, and clock is 1 all the time, so I'm saying J is 1 and K is 0. And let us see, this Q is coming up 1 here, okay? And since this is 0, since this is 0, one of the inputs to this NAND gate is 0, so it's immaterial what the other inputs are. This is gonna output 1. This is gonna output 1, because if I'm saying J is 1 and K is 0, because this is 1, this was 1, okay, this was 1 and this is 1, but this one is 0, the K input is 0 this time. So one of the inputs to the NAND gate is 0, it's gonna output 1, because AND will output 0, NAND will output 1. And what about this guy? This guy, this is 1, and this is 0 coming here. Okay, 0 is coming here, right? So when the 0 comes in here, so this is 1, but this input is 0. One of the inputs is 0 to this NAND gate, output is gonna be 1. So to my latch, 1, 1 is coming, because I know my latch, the inner part of this, the latch, if it is a 1, 1, it's a memory state. So that means it will retain 1, 0. So that's my set state. So that means if J is 1 and K is 0, if it was set, it will stay set. If it was reset, it will set. Say for example, it was not set, it was reset. Let's work it again. Say for example, this was not set, okay. 1, 0 is okay. Let me remove this, Say for example, this was reset. In the beginning it was reset, not set. And now I'm putting up 1, 0, that J1, K0 to it. Now let us see, will it set or not? Because I know this is like an S and R. If J is 1, it should set. If it was the set state already and I saw it will give the 1, 1, it's a memory state, it will retain that. Now, but it is reset state now. Now, will it make it set or not? Let us see. Now, this is 0. So, immaterial what is coming. Other inputs are, this is going to output 1. Right? Now, what about this guy? This is 1, this is 1. What's coming from this side? The 1 is coming from this side because this is 1, reset state. Q complement is 1. So 1 is coming to this gate, okay. Now all the 3 are 1, 1, 1, 1. What is going to be the NAND output? It's going to be 0. And we know the latch, If the 1 is on the bottom, it's going to set, okay. So that means it was reset, now it will set. So it will become 1, 0. So that means whether it was set or reset previously, if we are putting J1, K0, it is gonna set. Right? Same with the other inputs. Say for example, I will cut it short so that it will not become a long video. I am saying it is now 0, 1. clock is 1, it is 0 1. So it should reset. Right now it is set state. Let us see if I am putting it here 0 and I am putting it here 1. Will it reset or not? It is set state. And will I see if I make it 0 1, it should reset. So let us see it. Again, this is 0. One of the inputs is 0. To the NAND, output is gonna be 100% 1. Immaterial what the other inputs are. Okay, because NAND को उल्टा है, AND को उल्टा है. तो AND जब भी 0 देखेगा एक इनपुट तो वो 0 देगा, तो NAND इसको 1 देगा. और इस वाले में क्या आ रहा है? इस वाले में ये भी 1 आ रहा है, ये भी 1 आ रहा है, ये भी, यानी कि तीनों 1 आ रहे हैं. So when all are 1, output is gonna be 0. So I'm getting 1 0 to this inside latch, which was the original latch हमारी पुरखों की. उसको जब ऊपर 1 होता है नीचे 0 होता है तो ये रीसेट होता है, मैं पता है रीसेट होता है. So it will not be 1 0 now, it is gonna be the 0 1, the reset. Okay, if it was already reset and I'm putting it 0 1, so will it retain it? It should retain. It should put up here 1 1 as a memory state and retain it, right? Let us see. Now for this is 0, output is gonna be 100%. For this guy, 0 is coming up here, so 0 is coming up here. Immaterial what these are, it's gonna be 1 here. So 1 1 to the latch, inner latch. When 1 1 state to the inner latch, that's gonna be the memory state. So it's gonna retain that 0 1 state. So that means it will retain the 0 state, so it's a reset. So whether it was set or reset initially, if you put up 0 1 here, it's gonna reset. So it's working exactly same way the RS flip-flop or SR flip-flop was working, or even the D flip-flop was working. It's working same. In D flip-flop, we had no option of 1 1, but here we can have an option of 1 1. Where the SR flip-flop fails, it becomes unreliable. It was like having the race condition, but here it's not having a race condition. Let's try to see that. But because basically my JK flip-flop is mostly used because of the last state, that's the 1 1 state, because I want to tame that beast. Okay, so this is a 1 1 state. I'm trying to actually put it to use. It was not a beast at all, it was unreliable, so I want to put it to use. So that means I am putting J as well as 1 and K 1. And for our SR flip-flop, that was a problem. That was the race condition. But let's see. But it depends on, because now this 1 1 state depends upon the previous output, whether it was set or reset. Say for example it was reset, it was 0 1. Okay, so what will happen? So if this is 0, okay, the 0 comes up here and it becomes here 1, and this 1 goes here, 1 1 1, and output will be 0 of NAND. So 0 1, when 1 is on a bottom to this latch, it is gonna set. So if it was initially reset, now it will become set. Now again, okay, because clock is coming up, it will not stop. That's the problem with this. We have to think about it, because till the clock is going, because clock is coming from this side. This is my clock. It has some length, okay, some time span, the clock, and then there is another clock, and so on. Okay, say for example the clock comes up here, and the propagation delay of this gate is so fast, it's very fast, that it can do the same thing multiple times using this clock pulse. In a one clock pulse, it can do it multiple times. That means for example, clock pulse comes in, it toggled. Why toggle? Because it was reset, it becomes set. But clock pulse is still going. So will it stop? It will not stop. It will do again. These outputs will come back to the input. Now this one is 0. This goes here, and this from 0, this will become here 1. I will put it here. It becomes 1. Okay, and this is 1 now, because this is now set. This is 1 now. Now it comes back to it. Okay, everybody is 1, so output is gonna be 0. Now 1 on the top and 0 on the bottom to the latch means reset. So it will reset it. So it will become here 0 and it will become here 1. So it was like first the set, it was reset, it becomes set. Now it will become again reset, 0 1. So it's again toggling. So we say it's toggling, but clock pulse is still going. because propagation delay of this gate is smaller than the clock pulse. We cannot build the clock smaller than the propagation delay of this gate. That's the problem. So again these outputs will come back to the input. तो होगा क्या? होगा ये कि अब यहाँ पे 1 है, ये इसको जाएगा, ये तीनों 1 बनेंगे, so output will be 0 of this NAND gate, और ये वाला 0 है तो 100% ये 1 बनेगा. So जब 0 1 इसको आएगा लैच को, it is reset. तो अगर ये सेट था, ये सेट बनेगा जब 1 नीचे होगा. सो अगर ये रीसेट था तो ये सेट बनेगा. सो इट विल बी 1 and 0 अगेन टॉगल. सो अगेन दे विल कम बैक एंड अगर अब ये सेट था तो ये रीसेट बनेगा. मुझे कुछ काम आ रहा है, मुझे काम हो रहा है, टॉगलिंग हो रही है. सो व्हाट इज दिस कॉल्ड? इज अ टॉगलिंग. अब टॉगलिंग एक बहुत खूबसूरत चीज है जो काउंटर्स में हमें जरूरत लगेगी, लेकिन कंट्रोल नहीं है क्योंकि क्लॉक पल्स लंबा है. प्रोपगेशन डिले क्या होता है कि इनपुट्स इस गेट को आ गए और आउटपुट आ गए. इसका टाइम फॉर एग्जाम्पल क्लॉक पल्स, फर्ज कीजिए मैं जिस एग्जाम्पल के बता रहा हूँ कि क्लॉक पल्स आपका 1 घंटे का है, ये 1 घंटे का है, जस्ट एग्जाम्पल के लिए कह रहा हूँ मैं, और इसको 1 मिनट लगता है चलने में. तो जब तक 1 घंटा है तो 60 मिनट, तो 60 बार तो ये करेगा ना ऐसा, तो ये 60 बार ऐसा करेगा, ये टॉगलिंग करेगा 60 बार. टॉगलिंग क्या होता है? सेट को रीसेट, रीसेट को सेट बनाएगा. हालांकि अच्छी चीज है. अगर मैं इसकी तरफ देख रहा हूँ, मुझे 0 फिर 1 फिर 0 फिर 1, so इट्स लाइक अ काउंटर, इट्स आई कैन यूज इट. ठीक है ना? लेकिन प्रॉब्लम क्या है? प्रॉब्लम ये है कि मेरा जो प्रोपगेशन डिले ऑफ दिस फ्लिप फ्लॉप है वो बहुत स्मॉल है एज कंपेयर टू द क्लॉक. तो एक क्लॉक पल्स में बहुत बार फिर यहाँ पे नहीं करेगा कुछ. जब ये क्लॉक पल्स आएगा तो टॉगल करता जाएगा 1 स्टेट पे. ये किस स्टेट पे होगा? सिर्फ 1 स्टेट में. सो 1 स्टेट पे क्या होगा? सेट बनेगा रीसेट, रीसेट बनेगा सेट. सो वी कॉल्स अ टॉगल. So we call it a toggle state. We cannot write here 0 1 or 1 0 because if it is 0 1 it becomes 1 0. If it is 1 0 it becomes 0 1. So it depends upon whatever the previous output was. But it will not stop. Right? It will continue. It will continue till our clock pulse. So that's why we also read about what's called the edge triggered. This is called a level triggered flip flops where we work on the full level of this clock. Sometimes we make flip flops which will work on the edge. So that means it will work once only. It will not work in the whole. But to mitigate this problem, we will see in our next video what's called the master slave flip flop. Because what we want to do? We want to do what? We want that in single clock pulse it toggle once only. So we can say if it was set, it will become reset. ठीक है ना? अगर ये 0 था ये 1 बनेगा. इस तरह से Q कंप्लीमेंट भी, अगर 0 था तो 1 बनेगा, 1 था तो 0 बनेगा. तो मेरे को फिर इन दोनों में से एक चाहिए होगा आउटपुट. मैं दोनों आउटपुट नहीं लूंगा, एक ही आउटपुट लूंगा. तो उसमें देखूंगा मैं 0 फिर 1 बन गया, 1 बन गया, 0 0 बन गया, 1 एंड सो ऑन. ठीक है ना? लेकिन ये तब फायदा आएगा जब एक क्लॉक पल्स में ये एक बारी होगा, ये कंटिन्यू नहीं होगा. लेकिन यहां नहीं कर सकते, यहां प्रॉब्लम है क्योंकि यहां इंतजाम नहीं है हमारे पास. क्योंकि यहाँ क्लॉक पल्स आ रहा है, जब तक क्लॉक पल्स है तब तक आउटपुट्स वापस आएंगे. आपने आउटपुट दे दिए, ये तो वापस आएंगे ना, क्योंकि ये तो फीडबैक लूप है ना. तो फीडबैक लूप से ये आउटपुट ही चेंज करेंगे. अगर ये टॉगल करेंगे, अगर ये सेट था तो ये रीसेट बनेगा, अगर रीसेट था तो सेट बनेगा एंड सो ऑन. तो पहली बार में अगर ये रीसेट था फिर से वापस आ गए, ये सेट बनेगा. क्लॉक चल रहा है ना, अभी क्लॉक चल रहा है, अभी क्लॉक रुक नहीं रहा. तो फिर से वापस आके इसको फिर से वो चीज़ करेंगे एंड सो ऑन. सो सेट रीसेट रीसेट सेट, सेट रीसेट रीसेट सेट, इट विल गो ऑन, इट विल क्लॉक टॉगलिंग. तो पता ये चला कि हमने जो है कि ये काम नहीं कर रहा था. हमने इसको SR फ्लिप फ्लॉप में ये काम नहीं कर रहा था, ये अनरिलायबल था. तो हमने सोचा कि इससे काम ले, लेकिन ये बीस्ट बन गया. सो इट बिकम्स लाइक अ बीस्ट, इट बिकम्स अ ज़ॉम्बी. I don't want a zombie. So what do? We'll tame it. We will tame it. How we tame it? How we gonna tame it? We're gonna tame it by doing this thing, exactly speaking, by doing this toggling once in a clock pulse. How we exactly do that is using the master slave flip flop or edge triggered flip flop, which works on an edge, not on a level. Okay, that's why we have one more in our flip flop series what do you call it, sometimes types of flip-flop or something like that. We have one more thing to read that's called as a master-slave flip-flop. So that master-slave flip-flop is only to tame the beast of toggling. और इन शॉर्टकट में बोले तो कि एक क्लॉक पल्स में एक ही बार टॉगल करने का, बार बार टॉगल करने का नहीं, ठीक है ना। तो इस चीज़ को हम पकड़ेंगे नेक्स्ट वीडियो में इंशाल्लाह ताला, अगर अल्लाह ताला ने चाहा तो, ठीक है। तो तब तक आप क्या करेंगे, तब तक आप इस चीज़ का रिवीजन करेंगे, SR फ्लिप फ्लॉप से लेके यहाँ तक। इसको एक काइंड ऑफ स्टोरी याद रखेंगे, एक दो बार आपने देख लिया, काइंड ऑफ स्टोरी कॉन्सेप्ट में घुस गया, दिमाग में घुस गया, इट बिकम्स डैम इजी, ठीक है ना। सो सी यू नेक्स्ट टाइम, अंटिल देन, मा सलामा।